Hello friends, how are you? I hope you are doing really good. In today's video, we will solve a problem based on the method of section. In the previous videos of truss, we have seen all the basics of the truss and also solved one problem based on method of joint. So, what is this method of section? If we want forces in some of the members, then instead of solving joint after joint, we cut the members that are required forces and take any one side of the truss and solve for the forces. So here I want forces in these three members. I cut it and considered the left part of the truss and applied the equations of equilibrium. So this is the method of section. So let's solve the problem. Engineering Fundamentals Guidance by Somayya Sir, Pune, and I am Yugandhara Talele. Content of the videos are Introduction, Truss, its definition, what is statically determinate trusses, types of trusses, and do you know what are zero force member? What is a plain truss? Then we will solve problems based on the two methods. First is method of joints and the second is method of sections. Method of sections. And we will see some notes and one problem. So the typical procedure to solve the problems with method of section is like this. First, you have to draw structure FBD. So what is a structure FBD? When you remove all the supports and show the reactions offered by supports and the FBD is drawn, then it is a structure FBD. Now, consider a section which cuts members of our interest and find the reactions if required. So, this section is considered with skills. You have to consider such that it involves minimum number of unknowns. Then fourth step is draw FBD of the part of the truss on any one side, assuming member forces that are cut by section as tensile, and apply summation of Fx is equal to 0, summation of Fy is equal to 0, and summation of M is equal to 0, and find unknowns. Some important points about the method of section. First is when forces in few selected members of the truss are required, then only this method of section is used. Instead of solving joint by joint and then finding out the member forces, here the required members are cut with a section and the force in that members is found out. Second point is consider a section which cuts members of our interest, and that section should not cut the members more than 3 per section. Why? Because we have only 3 equilibrium equations. So for solving Number of equations is equal to number of unknowns. This is the mathematics. So only 3 members per section should be like that. Let's solve one problem based on the method of sections. So this is the given truss and member A, B, C, D and AE is there, EF and FD, and joint load of 20 kilonewton incline at an angle of 53.13 degrees is given, and at point A it is a roller support, and at joint C it is a pin support. And in the question it is been asked that we have to find a force between in the member BC, BF and EF. So let's solve it. First step in solving any problem is drawing the structure FBD. So structure FBD means removing the supports and then showing the reactions offered by those supports. So here it will be like this. Roller support will offer one reaction perpendicular to the roller, and the pin support will offer two reactions, one horizontal and one vertical. So this is the structure FBD. Reactions are shown. Next step is to find out these support reactions. Then we have our equations of equilibrium. But before, let's remember the sign convention. Force in positive x direction Fx is positive. Force Fy in positive y direction is positive, and anticlockwise moment is positive. So we will find the reactions. For that, we will take summation of moment at C is equal to 0. Why at C is equal to 0? Because from C through C, two unknowns are passing. So if we consider the summation of moment equation at point C, these two forces will pass through this point. So their lever arm will be 0, and these VC and HC will produce 0 moment. So these two unknowns will get eliminated. So applying summation of moment at C is equal to this downward reaction VA into lever arm 8 meter. And now this inclined force, you know, this inclined force is making an angle of 53.13 degrees with horizontal axis. So this horizontal component will be cos component, and vertical component, that is the remaining component, will be sine component. So this horizontal component will pass through this joint C. So it will produce 0 moment. But this vertical component, that is 20 sine of 53.13 degrees, is producing a clockwise moment. So it will be negative. So negative 20 sine of 53.13 into lever arm 4 meter is equal to 0. So we get VA is equal to 8 kilonewton. So we got VA is equal to 8 kilonewton. So let's show that in the diagram. So assume direction is correct. VA is 8 kilonewton. Now the next step is to determine the section. How to cut this truss so that we will get our required unknowns, the required forces in the required members. So we want force in BC, member BF and member EF. So let's give a vertical cut which will pass through these three members, as it satisfies the condition that we have three equilibrium equations and three unknowns. So we can apply equations of equilibrium. So this cut is okay. But we have to decide which part of this section we will consider for finding out these reactions. So let's consider the left hand part of the truss. Why? Because it has only one reaction. So it is easy to solve. So I have cut the truss at the section and drawn the half part, that is left part of the truss. For the members which have been cut, we have assumed them as tensile, that is the forces in the member as tensile acting away from the joint. So these are shown like this: FBC, FBF and FEF, and this angle is 36.86 degrees. Now we have these three unknowns and we have three equilibrium equations. Let's apply them, and don't forget the sign convention. Please always note it down before applying the equations of equilibrium. So we will apply summation of moment at B. So this point has been chosen very carefully. Why? Because through B our two unknown reactions are passing. So these two unknown reactions will create zero moment. Why? Because the lever arm will be zero. So these two unknowns will get eliminated and only one will left, FEF. So let's apply the equation of moment. Summation of M at B is equal to this 8 into lever arm 4 plus, why plus? Because this FEF is creating anti-clockwise force. So plus FEF into 3, lever arm 3 is equal to 0, which gives us FEF, that is force in member EF, is equal to negative of 10.67 kilonewton. Now we have another equation. Summation of Fy is equal to 0. Let's apply minus of 8, and now the inclined force. its downward component, sine component, okay, minus of FBF sine of 36.86 is equal to 0, which gives us force in member BF is equal to negative 13.33 kilonewton. Now, summation of Fx is equal to 0. What is that? Let's apply FBC plus this horizontal component of this inclined member FBF cos of 36.86 plus FEF is equal to 0. So after solving this, we get FBC is equal to 21.33 kilonewton. So we got the answers like this. And now we have to show them in the final diagram. So let's remember the sign convention for truss members. It is tension that is positive if arrows are acting towards each other, and if it is negative, it is compression, that is arrows are acting away from each other. Here, while solving the problem, we have assumed forces as a tensile, but for member FEF and FBF we got negative answer. So member FEF and F and member BF is in compression. So the forces are shown like this, and member FBC is having a tensile force of 21.33 kilonewton. So it is shown like this, arrows towards each other. So we will see the summary for truss. So plane truss, it is a rigid framework where all truss members are within the same plane and are connected at their ends by frictionless pins. External loads are in the same plane as the truss and are applied at the joints only. So this is the example of plane truss. Can you verify the differences between the plane truss and space truss now? So, a plane truss is statically determinate if the truss reactions and member forces can be determined using equations of equilibrium. If not, then truss is considered as statically indeterminate. We already saw the equations to determine how to determine the truss is determinate or indeterminate. Thank you so much to you all for being with me throughout this video. Happy learning! I am grateful for your support. We will meet in the next video. If you find this video useful, then please share. It will help others. And subscribe to get notified about the new videos.